does Watobe change teachers every year, every term? Ndakazi, I'm the grade 11 teacher, and so I teach all the grade 11 classes, and then someone else teaches grade 10, and we specialize like that. Okay, let's get going. So for those who are new, you are going to feel a little bit lost because this is the 4th lesson of the series. But the good news is we will, even if you feel a bit lost in the beginning of the lesson, later in the lesson, I'm starting some new stuff that will start from scratch. Remember that all our videos are recorded, so you can go back and see what I spoke about on the previous lesson later in the lesson as well. Okay, so the first question we're going to start with is this question over here, and I just want to talk you through it. The key word is to simplify this exponential expression. Now, this exponential expression is made up of 2 parts. There is the top part called the numerator and the bottom part called the denominator. Okay, so it's a fraction. The other part of this question is that there's a subtraction on the top and there's a subtraction on the bottom. And so because there are subtractions, because it's not a multiplication, we can't just use the exponent law straight away. And so I would love for someone who was in the last lesson to come online and share their thinking about the approach we might use to solve this question. So who would like to raise their hand and kind of just tell us, what do you remember from the last lesson that maybe could be helpful here? Yenzi, let's go to you.
I think we should look for a common factor first.
Okay, so Yenzi is saying looking for a common factor. Are there any other tips, Yenzi, you could give us?
I'm not sure.
Okay, no, that's fine, but that's a good tip. So a common factor and factorization. Who else might want to give us some hints? Kat, let's go to you. Kat, what do you think? What other hints could be useful here?
Hi.
Hey.
So I'm thinking you could do the what do you call this? The prime factor of 4, and then you expand m plus 2.
Ah, so what I think you were saying is you kind of write this last part here. Let me do what I think you mean. You do that. So I'll call that breaking down the term into parts. So let me just rewrite this like that. Take a moment. If you agree that, if you understand why this side is the same as this side, just give me a thumbs up in the chat. I call this step breaking it down. Sounds like a dance move, doesn't it? So, okay, now, if we look at the top and the bottom, what we notice is there is a common factor. I would like someone to tell me, what is that common factor? You can raise your hand or put it in the chat, whatever you feel comfortable, but I want the people of the room to speak to me or let me know their thinking. Can we, let's get non-causal. What do you think the common factor is?
I think the common factor is 2 to the power of m.
I think you are winning at life. Thank you very, very much. Okay, now I want to let you fly solo a little bit. So the first 2 steps, the first step was to break down. Well, I suppose the very first step was to recognize that this was a more complex question, but you broke down the terms into their parts, and now you found a common factor. I want to let you have a go and see if you can do the next step by yourself. And when you think you've done the next step, just say done in the chat.
Have a go at it, guys.
So just in this, when you feel like you've done the next step, which is to factorize the top and bottom, just say done in the chat. And then if you have a question, just raise your hand as well. We can have a bit of a discussion. The main thing I think most students are kind of wondering about, if you are confused, you're wondering like, how did this part over here kind of become this? And I want to ask you to think about law 1, which says if the bases are the same, you simply add the powers. So there's no reason why you can't go backwards and say, well, if you've got 2 powers, you can break them apart and have the same bases. That's kind of my thinking that I want you to look at. Okay, so what we're going to have on the top is we're going to take out the common factor. And on the bottom, we're actually going to take out the same common factor. And now you have to ask yourself, what is going to go inside the bracket? Now, remember, this technique of factorization is called taking out the highest common factor. And when you do this, it should be reversible. It's equals. So what was left behind when you took the 2m out? All by itself, well, let's even use a different color. The 3 is left behind. And so if I want to be able to get back to this one day, I have to put a 3 over there. Okay, so that's because 2 to the power of m times 3 will give me this. Now, what's left behind on the other side? Well, what's left behind is basically all of this. And so now what I have over here is I'm going to have minus 4 times 2 squared. Give me a thumbs up in the chat if you understand that part. Okay. Fantastic. Now let's see if you can get the bottom row. See if you can do it by yourself. Ask yourself, what do you think is going to be in this next bracket? And why don't you tell me in the chat, if you can, what's going to go in this bracket here? It's a little bit sneaky. There may be a reappearance of the phantom from the earlier. Those who were at the earlier lesson will know what I mean. I'll explain now. So if I took the 2 to the m out, for this first one, if I take it out, there's nothing left behind. Well, actually, there is something there. There's always a 1 in front. And so if I want to say 2 to the m times what gives me 2 to the m, it's just going to be 1. And then what is left behind on the other one, it's just going to be this and this, which is minus 2. So now we're not finished this question. And there may be some more questions. So for the rest of you, if you feel comfortable, I want you to try and get to the final answer. For those who have questions, I'd love you to raise your hand and we can have a chat. The rest of you, I want you to get me a final answer. What's your final answer here?
Mr. Is, we have a hand from Tebogo.
Tebogo? Let's unmute Tebogo.
Hi.
Hey.
I have a question. What for the denominator? Why is it 1 minus 2?
Okay. Can you see that the 2 to the m got taken out of here?
Mm-hmm.
And it went to the front.
Yes.
Now, what is left behind when you take the 2 to the m out? Can you see the things in green? Would you agree that's what's left behind?
Yes.
So that's why this bit is minus 2.
Oh, okay.
Does that make sense?
Yes.
Fantastic. So we're going to cancel these 2 out. And what are we left with? Well, I suppose 3 minus 4 is 4 times 2 squared. It's 4 times 4. So I've got 3 minus 16 over minus 1, which gives me minus 13 over minus 1. And so my final answer is going to be 13. So take a moment to look through that. And see if you agree with me.
Mr. East?
Yeah. Is there a question?
Yes, Conde said that he had poor connection because of load shedding. Is it possible to explain again what we're doing in this question?
Okay, I'm going to go from the very top, and then we'll kind of. The other good thing is I will talk about this type of question at the beginning of next week's lesson as well. So step one was to realize that the top and the bottom both have what's called, well, the first part was to split it apart. So 3 times 2 to the m minus 4 times 2 to the m times 2 squared, that's the splitting step. Then you'll notice I take out what's called a common factor of 2 to the m. It's yellow. And so that is why there is a common factor over here. But when you take out this common factor, you still have to think about what's left behind. So that's where the 3 was left behind here, and the minus 4 times 2 squared is down inside here. And the same thing is happening on the bottom. What's left behind? There's a 1. What's left behind? There's a minus 2. Then 2 to the power of m divided by 2 to the power of m is 1. It's nothing, or essentially 1 is we ignore it. So now we go, what is 4 times 2 squared? That's just 4 times 4. So that's 16. So what's 3 minus 16? That's what's going to happen here. What's 1 minus 2? It's minus 1. So then I go 3 minus 16 is minus 13. Divided by minus 1. Well, a negative divided by a negative is a positive. So it's positive 13. For those who feel very lost, don't worry. This type of, there's a recording where you'll be able to rewatch this. And it is a tough question, but because you're in the standard class, I am including this type of question. And I will go over another example like this when I go over test correction. So we're going to do a quiz today, and you can try it. And then I will go over the question like this in the next lesson. Okay. All right. So let me move on from this type of question for now. If you need to take a screenshot, though, of this, if that would be helpful to you, some who may want to just relook at this. Also remember the recording in the last lesson has a couple of questions like this. So give me a thumbs up if you're ready to move. We can move on. You've taken your screenshot and we are ready to roll onto the next part. Okay. Let's start with something a little bit simpler and a little bit different. How do we deal with powers that are fractions? So I'm going to give you the question, 16 to the power of 3 over 2. And I want everyone to just try and do this question using whatever method you know. So 16 to the power of 3 over 2, solve it in whatever way you can, and then tell me if it's A, B, C, or D. No calculators, sorry, that's the other thing. No calculators, this is just using laws of exponents. And for those who feel very comfortable with this, tell us in the chat, what do you think the first step is? What's the most important step in solving this type of question?
Any wise advice, guys?
We love it when you share your thinking. We love it when you breaking down exactly, Ntando. You've given us some awesome advice. Now, there's 2 ways that you could do this question. The one way is to say 16 is 4 squared, and you write it like that. Or you could write 16 as 2 to the 4, like that. Both ones work fine. Now you apply what's called law 3, the power law, law 3, where you say, if 2 powers are next to each other like this, you can multiply them. So we would get 2 times 3 over 2. And so if those 2 cancel, we get 4 to the 3 or 64. Or if you did it this way, you just say 4 like that. And then you get 12 over 2. You get that. And that will also give you 64. And so the correct answer is that. So what I want to point out is that powers that are fractions, we can deal with powers that are fractions, and the laws of exponents apply just fine to them. So there's nothing scary about fractions that are powers. Let's move on to another one. Take a screenshot quickly if you need to for this question, but I liked what I saw in the chat. Everyone, it looked pretty good to me. Just raise a question if you think I'm going too fast, but let's try this next one. What is 1 over 16 to the power of minus a half? And you may only use your brain and a piece of paper, no calculator here. And then if somebody is willing to share their thinking about how they would approach this, just pop your hand up. We'd love to hear from you. And again, you don't have to share even the answer, just your thinking. Like, how are you, what approaches are you using to solve this problem? Or what rules or laws? Yeah, let's go to Pumunte. What approach did you think of?
So I'm not exactly sure how to put it, but I said 1 over 16 is the same as 2 to the power negative 4. I put in the bracket and raised it to the power negative 1 over 2.
Can I suggest that you did 2 steps in one, which is completely fine. You first did that, and then you did that. Is that fair?
Yes.
And what's step after that?
2 to the 2.
Yeah.
Negative 4 times 1. It's going to be positive 4 over 2, which is 2 squared.
Okay, so you're going to get, yeah, so you negative 4 times negative a half is just going to be positive 4 over 2, or
Yes.
positive 2 squared. And so I assume you got B, huh?
Yes, sir.
You are winning at life. Well done. Love it. Love it. Okay. Let us make it a little bit more tricky. So can you solve this one? What is 8 over 27 to the power of minus 2/3? No calculators, just your understanding of exponents and this. Oh, bring it closer. Okay, no problem. How's that, Tom Dakazi? Is that a bit better?
Mr. S?
Yes.
Tandoletu says she's feeling a bit lost.
Okay. I won't, if I go back to the other one, I'm gonna have to zoom out. So can I suggest, Tandoletu, in this question, focus on the 8 and 27. All right. So what can you do to the 8 and what can you do to the 27 that you've done before that might help you deal with the minus 2/3? It's quite hard to raise to, like, say, to the power of minus 2/3 just in your brain. And so I want to ask you, think about what you can do with the 8 over 27. I was thinking and maybe some others agree with me, I don't know, you can let me know in the chat. Can't 8 be written as 2 to the power of 3? And 27 could be written as 3 to the power of 3. Now, I want to know, that's helpful, but what is the next step after that? Like how could I use that like transformation to my advantage? I'd love to hear from someone in the class. What do I need to do now to get me on the road to the answer?
We have a hand from Beverly, Mr. Ace.
Let's go to Beverly. Beverly, what do you think?
Hi, sir.
Hey.
So since the fraction is in brackets, you must multiply all the exponents with the outside exponent.
Exactly. So there's actually 2 ways you can do it. The one way is to multiply, like you're saying, is to multiply this by this and this by this. Or you could also move the 3 outside. So both methods are correct. I'll follow your method that you said there. So you said go like that, and then go. Beverly, is that what you're saying?
Yes, sir.
Perfect. Okay, what's the next step after that?
And then 3 over 1 times -2 over 3 gave me -2.
So on the top, basically these 3's cancel and you get that.
Yes.
Okay.
Sorry.
Go for it, yeah.
And then the same for the denominator because the exponent is the same as the yeah.
I feel like you're almost home and dry. Now, the problem I'm having, Beverly, is that there's no option in the answers that match yours. Can you give me any further help?
And then since the exponents are negative, you're going to swap the 2 numbers so that they can have positive exponents.
So you get 3 squared over 2 squared, which I see now is 9 over 4 and is D. Yes, I understand. Thank you, Beverly. That is really good. Really good. Okay, I feel like everyone has got this waxed. And if not, some extra practice in the quiz today will help you along those lines. Paul, I see you have a question. What is your question? Let's go to you. Paul, what is your question?
Hi, sir. So since we know that 2 to the power of -2 is just basically going to be 1 over 4.
Yes.
3 to the power of -2 is 1 over 9. Why don't we just say 1 over 4 multiplied by 9 over 1, which is going to give us 9 over 4. Will that still be correct?
Yes, and Paul, that's sneaky. That's, yes, completely correct. And it does save you some time. So it's a balance between using the fastest method and thing, but that's completely correct. You obviously understand your fractions and your tip and times idea very well. Yeah, completely fine. Yeah. All right. So before our break, we're just going to do 2 more little multiple choice questions, but this is slightly different. We are going to now do what's called an exponential equation. Very simple exponential equation. And I want you to try and use what you've learned about exponents so far to solve this problem. If 8 to the power of 8 is 2 to the power of n, what is n equal to? And I want you to give that a go and see what answer you think is correct.
Mr. Ace, can you see Tandaletu's question in the chat?
Okay, Tandaletu, I get that when sir. Okay, let's have a look. What if the exponents don't cancel? Ah, okay. Tandaletu, we are going to deal with that situation a little bit later when we deal with surds and things. So at the moment, I am choosing examples where things are canceling out because it is a bit neater, but we will, there are situations where it doesn't, but we'll talk about what that means when we talk about surds and like things that aren't perfect squares and stuff. So for now, I'm going to ask you to just pause, but it's a very good question. I'm impressed by your insight there. Okay. Okay, so I think a lot of people are going for B, and I think what they've realized is that 8 is 2 cubed. So basically I can rewrite this like this, and then using the power law, this is 2 to the 24 is 2 to the n. And so then if the bases are the same and the whole thing is the same, surely these two have to be the same. And in simple exponential equations, the idea of making the bases the same on both sides to solve the equation is a very important technique. And so I just want to take note that this technique helps you solve a lot of exponential equations. And so the correct answer is B. Absolutely correct. Okay, one more. I know I'm really pushing you today, but one more before the break. Can you solve for me? What is the value of n in this particular problem? X to the 8 divided by x to the 10 to the power of a half equals x to the n. See if you can do that. But I like what I'm seeing. I think I can feel the good understanding of exponents coming through here.
Looking good, guys.
Exponents are a bit like, it takes a while to get used to. They're almost like they behave a bit differently with their own little laws. And I always remember, like, when it clicks, you kind of like, oh, okay, it does take a while.
Have that aha moment.
Because it's that powers to the powers, and then you're multiplying, and sometimes you're adding, and just knowing where that separation is. Okay, so from what I'm seeing in the chat, Emmanuel, Tebogo, I've gone for A, and a lot of other people have as well. I think you must be doing the subtraction law to get this for step 1. Because 8 over 10, you just subtract the powers. Then you've got -2 times a half, which is -1. And because the bases are both x, so -1 must equal n. Yeah. So the correct answer is A. All right. I have pushed hard and we've done a lot of work, and our bodies now need a break. So I want to invite you to step away from your chair and join me in indulging in a bit of stretching and a little bit of playfulness. So turn on your cameras. Let's stand up. And let's...
Please join us in this stretch, guys. Put
Okay.
on your cameras. Let's see your lovely faces.
Let's take a moment and just roll our shoulders, because we've been leaning forward, probably crouching and putting all the weight on our head, and our shoulders are stressed. So we're just going to roll it back and feel how nice it feels. And then roll your shoulders forward and just shake it out. So your body is probably a bit tense. It's been sitting and concentrating for half an hour. Your brain needs a break. You need to give it a pat on the back. And then stretch your neck out as well. Stretch it to the left. Stretch it to the right. Okay, so that was good. Okay, now what we're going to do is we're going to do a little midline crossing exercise. So take your right hand, place it on your nose, and take your left hand, I know I'm the other way around, and put it on your right ear. Okay, now what you're going to try and do is you're going to try and move this hand to your nose and this hand to your other ear. Try and do that. And now try and go from here and here back to this. And try and see if you can switch back again and see how your brain wants to fight you. And then as it becomes, it's actually quite hard, see if you can switch back and forth. And if you practice all day and night, in one day you'll be able to do it as fast as this. Okay. Did it feel hard? Let me know in the chat. Was that difficult? Or was it easy? I'm interested to know. Okay, let's just do one more stretch. Let's do a tricep stretch. Nice tricep stretch. We're really trying to take away all the tension in your shoulders. And then let's switch to the other side. And then just shake it out. Shake it out. And then hopefully your brain is feeling thankful and a bit more chilled and relaxed after half an hour of mathematics. And let's do this. So this is your puzzle question for the day. I want to know, what is someone who's in love plus someone who is happy? So basically this bit at the bottom, what is that equal to if you know all this stuff over here? Let's see what you can do.
Emojis.
No problem, everyone. We were just stretching it out. So
Oh, I missed out on the stretch.
I know you could just give yourself some time there. Just roll your shoulders. We did the whole just relaxing the shoulders thing.
We'll do Mr. Ace.
So I think it's fairly obvious that this is 132 because, but then the question is, what is the guy with the sunglasses worth? And
Ooh.
if it's minus 132 on the one side, I think I can add 132 to both sides. And if I do that, I get 200 for the happy smiley man. Or not the happy smiley man, sorry, the sunglasses. Am I being correct here? Yeah. 200 plus. Oh, wait, no, that's not correct. That's 200. So this is plus what is 300? This must be 100, which means this must be 100. And Relo Bugile and Inati have already got their chop chop. And so is Pumunte. So for me, the correct answer is 232. Because it's 132 for the smiley face. It's 200 for the sunglasses. And then that means the person who's in love is 100. And so the final line is 100 plus 132. And this is what we call a
Awesome, guys.
equation. Yeah. Well done. You'll see that each time you do these, they get a bit easier. And so when we even do simultaneous equations, you'll know a lot. Okay.
Remember the emojis.
Exactly. I like the emojis. It's quite original too.
Yes.
Okay, so let's keep going with the lesson. What I want to do now is I want to focus on working with, let's have a look. What should we do? If I said to you, I'm going to work on question 3, 4, and 5. So let me put this a little bit further down, and then I'm going to let you loose on this question. Oh, why is that not working there? Now, in order to do question 4, we may need, oh, let's see how you go. So let's try and do question 3, 4, and 5 that are on the board right now. And once you get your answer, you can put it in the chat. But let's start with 3, in fact. So, and then if you're feeling comfortable, try out 4. And if you're feeling comfortable, then you can then go on to 5. Okay, non-Pomolelo is given the answer to 4, but we also want the answer to 3, and we want the answer to 5 as well. Hmm. So the answer for number 3 should be 2a squared b to the 4. See if you agree with how I got that. If you have a question, feel free to raise your hand. And then I would love for someone who solved number 4 to maybe come online and give us how they thought through number 4. Because number 4 has this funny square, or not square root, but it has this root bracket. And we haven't really spoken about the root bracket yet so far. And so I'm wondering if somebody can maybe share with us their thinking about what is different about this root bracket, or how do you handle this root or radical sign? I would really appreciate anyone who has seen that before and maybe has some thinking.
Any ideas, guys?
What does that 5 outside mean? Kat, let's go to you.
So for the root, I know
Yes.
that the squared inside of the root, the 32 squared inside of the root, you're going to make, what is it? A fraction, and the 2 is going to be on top, the 5 at the bottom.
Okay, so you, I think, are converting it from what we call as root form to exponent form. So you're changing, okay, how do you do that? So you've got 32 squared, and now instead of having the root bracket, what do you have instead?
You have the 5 as the denominator.
You have this, so basically the 5th root of something is the same as the power of a 5th.
Yes.
Okay, perfect. That is super helpful. So when we say the 5th root of something, we can also write it as to the power of a 5th. And that's the tip that we needed to solve this. So I'm going to hand it back to everyone to try and work it out. But that was super helpful. Thank you, Kat. What do we think the answer is for number 4 then? So we've got 32 squared to the power of a 5th. I suppose using the power law, we could rewrite that as that. So basically we multiply these two. Oh, I know, the 32 needs to be broken down. So I write 32 is 2 times 2 times 2 times 2 times 2. So it's like that. And so now what is our final answer? So again, we multiply the powers and the 5s cancel. And so we get 2 squared or 4. Beverly, you're on fire. Okay,
Mr.
so
S, are you able to take the question?
yes, I am. Pumunte, let's go to you, and then we'll go to Mpho.
So I wanted to answer the question, but then somebody else.
No problem, not at all. Thank you for assisting us. Mpho, what's your question?
So, sir, I took a different approach to answer number 4.
Okay, tell me what the approach is.
So it is still the radical sign with the 5 outside, and I
Yes.
just write 32 as 2 to the power of 5, and then the 5 inside the radical is going to cancel the 5 outside. Therefore, the root sign falls out, and then we're going to be left with 2 squared, and 2 squared is equal to 4.
Aha. Okay, so if I'm understanding, there's different ways of understanding this, but you did something like basically all of those powers are being multiplied.
Yes.
And so what you said is, look, I mean, that's again, it's completely right. This and this can cancel. And so all you're left with is 2 squared, and therefore it's 4. It's completely correct. It's just you really have to understand the law as well, but that's completely fine. Yeah. Perfect. Okay, are there any other questions about that one? Otherwise, we could all go on to number 5. And there's
Mr.
probably,
Ayres,
yeah.
sorry, Mr. Ayres, can you
Yeah.
please explain number 4 again for Thandolwethu?
So Thandolwethu, what I first had to understand was that taking the 5th root of this is the same as the power of a 5th. So that's step 1. Step 2 is to realize that let me get this. Step 2 is to realize that the 2 can be multiplied by 1/5, and that gives you this, the 2/5. Then I focus on the 32, and I say 32 can be broken down into 2 to the power of 5. I'm sorry, that color is not the greatest. And then I multiply the 5 by the 2/5, and that is going to cancel out. So basically this over here is going to cancel this. And what am I left with? I'm left with 2 squared, which is 4. I hope that is a bit helpful. So number 5, there's a lot of negative signs going along, and I'm wondering, what is the first step? As I look at it, the thing that irritates me the most is this bit over here, but there's different ways of doing it. So I thought I might start by working with this stuff. It feels that everything inside the bracket is quite messy, and I need to maybe break it apart. So what we could do is we could say on the bottom, -2 to the power of -2 times x to the power of -2. And on top here, we could leave this like that. And then the -3rd, we're leaving alone. So what I thought is, let me start by doing that, by breaking down those parts. Would you agree with me? Like, give me a thumbs up if you kind of notice my approach. Well, the -2x inside the bracket for me just feels like complicated. So I thought, well, I know the laws say that I can break it apart. So I'm just taking what's inside the bracket. So each of these things, -2 has its power, and so does x. And I'm applying the -2 to each of these items. Now what I'm going to do is I'm actually going to move these things from the bottom to the top. So what do you think is going to happen to the -2 to the power of -2 when it goes to the top? So what do you think is going to happen to this term when it moves to the top? What do you think is going to happen to this term when it moves to the top? The sign changes, yes. So I'm going to pause for a second and see, can you finish the question from this point? Can you see if you can get to the finish line there? Because I think that's a big hint, and then I want to see what answers do we get.
Keep going, guys. We believe in you.
Yeah, we can do this.
We have a couple of different answers coming in.
I like it. It means that there's some interesting learning going on. So in my approach, I see the x to the -2 times x to the 2. And you know what? That is actually great news because I'm going to get x to the 0 and x to the 0 is 1. And so basically that goes away. So then all I have to deal with is -2 times -2 times -2. Now ask yourself, what do you get when you have -2 times -2 times -2? I think we get -8. So we're almost done here. What we now, this is actually quite a tricky problem. So now what do we need to do? I think what we need to do, what are the answers? There's a couple of different answers coming in here. Let's have a look here. -2. You know what? Let's actually not do it like that. Let's do it like this. Let's leave it like this. I've got -2 squared times -2 to the power of 1. I'm just going to get -2 to the power of 3. Because there's 3 -2's that are being multiplied. And then outside that, there's going to be -1/3. Now, I'm going to multiply the 3 by the 3rd. Okay, so this, and I'm going to get -2 to the power of -1. And then the last step is going to be to bring this below the line, and I get that. And so the correct answer is -1/2. That was actually a lot harder than I expected. So, I mean, if you followed that completely through, you really are, you know, like that was a decent level question. Are there questions for me to clarify now? I suspect there might be a couple of questions, but that was a bit of a toughie. But that's also nice to see some of the harder questions too. Okay, let me look at the questions. So I think most of you are happy with this part. So this part is done. And then what I said was there's -2 to the power of 2 times -2 to the power of 1. That's the same as -2 to the power of 3. Now that is a bit more tricky. So this bit over here, understanding why this is true and why that comes from here is something that I want to just check that you understand. And then what we have is we have 3 times a -1/3, and that's going to give us the -1. But now if you have something to the power of a negative and you want to make it a positive power, you bring it below the line. So that's why this becomes positive here. The -2 just stays in the bracket. And so now we just have 1 over -2, which is -1/2. It's not wrong to leave it in the denominator. So one of the questions was, can you write this as -1 over 2? That's completely, utterly correct. Perfectly fine. Okay, so take a screenshot now if you need to. That was a genuinely tough question. Cass, do you have a question? Let's go to you. And then I'll come to Ntokozo after that.
Hi, sir. So
Hey.
I wanted to ask, the denominator, how did you get it to times the numerator in step number 2?
Okay, so the denominator times the numerator. So you are talking about this step over here?
Yeah, how did you get the denominator to times?
Do you see that when I take it above the line, can you see the negative power? Can you see when this goes up, it changes from a -2 to a +2 in the next line?
Okay, yeah.
Okay, And then can you see that the -2 down here, it reappears as a +2 in the next line?
Yeah.
And so when I move it up, it changes from a negative to a positive. That's what I was doing.
Okay. Okay. Thank you.
But that's tricky. I agree. That is tough. And Ntokozo, what's your question?
So I used a different method, but
Okay.
the answer was the same, but positive.
Okay. You're very, very close. You probably just made a little error at the end. You still would have got 4 out of 5 marks because there's the potential to make silly errors here. So if you were that close, I'm pretty happy with what you were doing. Okay.
Okay, thank you.
Cool. All right, we're almost done for today. There is 1 or 2 questions on what to do that. I just want to do, I know I'm pushing you hard, but just quickly see if you can solve question 1. In your quiz today, there's a couple of exponential equations, and I want to just make sure you have some exposure. Tell me what the answer is to question 1. So 2 to the x equals 8. Okay, so that is not too bad because you just do that. Okay, so you understand the technique. Then the last question for today, can you solve this exponential equation? And the tip I'm going to give you is that the way to solve an equation like this is for the bases to be the same. So can you solve this equation for x? I will finish this one tonight, and then Lebo, as we are finishing off here, can you just get the link ready for the quiz so I can give it to students so they have access to the quiz link?
Will do, Mr. Ace.
Thanks. If you feel like you know what to do as a first step, won't you put it in the chat? Give us a hint as to what you think might be a good place to start. Breaking down to primes. Yep. The fact that 125 and 5, they might have something in common. So I think that is not a bad first step. So let's do that. Okay, now I agree. Tandoweto and Ndokazi, we are winning at life. But what is my next step? It was so much easier earlier on when I had 2 to the x equals 2 to the 3. Is there some way we could use that thinking to help us solve this one? What do you guys think we need to do after this? You can't quite drop the bases yet. Can you see that this whole term is negative? If I moved it to the other side of the equation, if I moved it, it would become like this. So what I could have done in step 1 is I could have moved this to the other side as well. So I could have written it as like that. And then in the next step, I would have broken it down. Okay, keep those answers coming. I'm going to put the answer on the board in a second. The next step is that side is not very complicated, but this side is going to actually become 6x minus 9. And now I feel comfortable that we can drop the bases. So now I feel comfortable that we can drop the bases. What is my final answer going to be? So the bases are the same. So we get 2x plus 1 equals 6x minus 9. Which then means we get 1 plus 9 equals 6x minus 2x. 10 equals 4x. And 10 over 4 is x, or x is 2.5. Or 5 over 2. Okay, now that was again a bit of a toughie. But I just wanted to, there are some questions like this in your quiz. And so I wanted to give you at least one example, or there's one question like this in your quiz. The question is also, what was the mark allocation in the test or exam? I would probably say 1 step for moving it over, 1 step for moving it over and doing the prime base, 1 step for multiplying out, 1 step for equating, and there might be a mark here and a mark here, or it'll either be out of 4 or 5 marks. Yeah. Okay.
Mr. S, we have a hand from Yenzi.
So can I ask, I will come to Yenzi's question now. For those who feel comfortable enough, Lebo, could you put the link to the quiz in the chat? If you feel okay, guys, you're welcome to go off and do the quiz. It's been great teaching you today. And for those who are feeling unsure or just want to ask a few more questions, I will stay on for a minute or two more. So let's go to Yenzi. Yenzi, what is your question?
So if you said, you see for the second step, where you put the x's on one side and the digits by themselves. What if you said -9 minus 1?
Yeah, I lost you for a second. You're not at this first line. Are you on this line here?
No, for 2x, for the one at the end towards, for 2x plus 1 equals to 6x minus 9.
Yes, if you said what at that point?
If you said -9 minus -1 instead of taking the 9 to the other side.
Oh yeah, that will still give you the same answer. So 2x plus 1 equals 6x minus 9. And you're saying you get minus 10 like that. And then you get 2x minus 6x is minus 10. So you get minus 4x is minus 10. But then you still get minus over a minus, which gives you a plus. So you're fine. Same answer.
My question is, so it doesn't have to be exactly like this, the layout, as long as you got the same answer.
Yeah. No,